Hello everyone, welcome to the sixth and last webinar of the PDBe API webinar series. My name is Mandar Deshpande. I work as a web front-end expert here at PDBe. In today's webinar, we will discuss in detail about data visualization at PDBe. This webinar is divided into three sections. First section is about the fundamentals of data visualization. In this section, we will see how we choose and finalize a data visualization design. We will also briefly look at the architectural overview of an individual data visualization. In the second section, we will explore all the publicly available data visualization resources provided by PDBe. Here, we will learn about all the go-to places and how to explore them for any required information. And in the third section, we will take a couple of examples to demonstrate integration of PDBe Molestar and PDB Vista data visualizations into a web application. So let's start with the fundamentals. So what advantages we'll look for in a data visualization at PDBe? Primarily, we want the data visualization to provide comprehensive view of the data. The comprehensive view should also be easy to explore, especially when the data set is a complex one. We also want the data visualization to help find correlation between different data types. It should be interactive. We want it to be more than just a static image display. With interaction, user can easily explore specific regions of their interest. The data visualization should communicate desired and relevant findings, and it should also provide links to resources which are more details or which has more details about that particular data. So as we know that the data visualization needs to be comprehensive, it is difficult to include all the details in the visualization design. So by providing crosslinks, we make sure that the users don't miss out on any information, and they can also explore the data in detail in other specific resources. So how we choose a data visualization? In the beginning, we'll look for standard representations for a particular type of data. And we look for standard icons, we look for standard logos if there are any available, feature viewers, 2D, 3D views. And then we customize and extend these standard representations for our use. We also do an extensive user experience exercise. For that, we identify different users. For example, we identify users across different domains. We identify users for different expertise. And then we try to understand different scientific questions which needs to be answered with this particular data visualization. Now, once we have this information in our hand, we do design exercises like sketching, creating wireframe mockups. Followed by this, we get to do a lot of user testing. We do feedback gathering with this and design improvement steps. The last step of design improvement is done iteratively until we finalize the design. At PDBe, we provide multiple services which are developed using different web technologies. That's why after finalizing the design, what we do is we create standalone web components and plugins for that visualization. These standard web components are then integrated across our different applications and services. So this way, we can make sure that our users get consistent user experience across all our services. Most of our data visualizations are publicly available. They are listed in our PDB component library. We list them in the bio.js library. We make the source code available on GitHub, and we also create NPM modules for these visualizations. Let's have a quick look at the design overview of a standalone data visualization. A standalone data visualization at core is a plugin which is developed in TypeScript or JavaScript. So this plugin implementation allows you to integrate the data visualization using the classic vanilla JS style. So in this, you can create an object instance and can call just a render method on top of it. We create a web component wrapper on top of the plugin implementation. With this implementation, you can use the data visualization as custom HTML element and directly add it to your web application template. So if you are using any latest JavaScript framework, then you can also take advantage of the advanced features like property binding with this implementation. Our data visualizations are powered by multiple REST APIs. So what we do is we get this required data from multiple resources and then arrange it into a metadata model. This data model is then used to drive the rendering functionality. So if anybody want to use our source code and customize the data visualization for their own data, they can easily reuse the rendering functionality by just arranging their data in that particular required data model format. Let's move on to the second section now. We will discuss about our publicly available data visualizations and how we explore them. Currently, there are 8 data visualization web components which are publicly available. Many of these are developed in collaboration with different teams. These include both internal EMBL API teams and teams from outside API. The main purpose behind this collaborative effort is to develop an easy to use and a reusable data visualization resource, which will provide a consistent user experience. The PDBe component library webpage is a one-stop shop to get information about all the publicly available data visualizations. For each data visualization, here you will find a description section which has a summary information about the data and how it's the depiction created from it. This description section also includes information about the teams participating in the collaborative development, and you will find important resource links like links to the GitHub source code and wiki documentation. We also provide an editable working demo over here. So you can try out different visualizations options here itself without any need to set up and configure the visualization separately. The project's GitHub README file has the basic information about how to set up and build the source code locally. So once you get the source code, you just go through the README and you can set up it locally on your machine. But then we use GitHub Wiki extensively to provide detailed technical information. So this wiki contains details about the different ways available to integrate the data visualization. And it also has information about different options and parameters available to customize that visualization and links or working examples where you can play and see the functionality actually in detail. But this is the online IDE called Plunker. We use this to share working examples. These examples are editable and can be used to test different options and functionalities. And for this, you don't need to download any setup, or you don't need any files to have it locally to run and test them. In this demo, you can fork these examples and create your own demos as well. And you can share this demo URL with other people. The IDE also provides an option to download this example codes, and you can just use it on your local machine again. Now we will take a look at a couple of examples now to demonstrate the integration steps, how to integrate this visualization into a web application. First, let's see how to integrate our PDBe Molestar 3D viewer. For integration, we start with adding the visualization library files or build files in the web application. PDBe Monster is available as both JavaScript plugin and it's also available as a web component. So for plugin implementation, you will have to include the style sheet files and the plugin build file. For web component implementation, in addition to the style sheet and the actual web component build file, you will also have to include the web component polyfills as well. As web components are not yet natively supported across all the browsers, these files are not necessary if you are using plugin. But for web components, you have to add this polyfills. So for any reason, if you feel that this is an overhead of downloading this data to your web page, we recommend you to use the plugin implementation. We host these library files for all the visualizations from a common location. These files are then used in our live applications. So you can actually use these files directly from this application location, and they will just serve as a CDN like we use for jQuery or T3. The advantage here is that you don't have to locally build or host these files. Also, these files are versioned, so you don't have to worry about any breaking changes being served accidentally. Once you include the visualization build files, the second step is to create and render the instance. For plugin implementation, you first have to create the instance object of the plugin. Then you have to create a variable object with options as key value pairs. Here I have set the molecule ID to 6M2Q. It is a recently released PDB entry related to COVID-19. Then you have to get the container element inside which you want to render the 3D view. Here I'm using get element by ID selector. You can use any JavaScript selector to get this element. Finally, you have to call the render method for the instance object. This will render the viewer 3D viewer instance in your web application. For web component implementation, you can directly include the visualization as custom HTML elements in your web application. And in web components, you just have to provide the options as attributes and HTML attributes. That's it. Just 2 quick and easy steps, and you can include the visualization in your own web application. Our PDBe pages, you might have noticed that a visualization is presented in different formats. So these are actually context-specific customizations. That's why you will find different 3D views present on our entry pages. Like there is an entry view, you can see also an assembly view. We also provide a 3D view for ligand interactions. What we do is we parameterize these customizations so that users implementing our visualizations can render the same context-specific views in their own web applications. For example, here you can see a picture showing superposed structure cluster for a recently released COVID-19 protein. This 3D view screenshot is from our PDBe KB aggregated views of proteins. To render this same view in your application, you just have to specify a few parameters in the PDBe Molsa instance. So here, along with the UniProt accession, I have provided a couple of superposition related parameters to render this view. All the available parameters to customize a visualization are listed in our wiki documentation. Check out the news article URL mentioned here for more information about our recently released superposition functionality. We will now take the second example. We will check how to integrate PDB Prot Vista viewer. So Prot Vista is a standard feature viewer which shows linear representation of a sequence of a protein and depicts value-added annotations from different resources. Recently, the old ProtVista plugin was redeveloped at ABI as a reusable web component. It was named under a project called Nightingale. PDBe ProtVista is our customized implementation of these Nightingale web components. To integrate PDBe ProtVista, the first step again is to include the web component build files along with the required polyfills. After including the files, PDBe ProtVista instance can be directly added as a custom HTML element in your web application template. The rendering is driven by completely data-specific metadata structure. So you can easily display your own data in ProtVista view by providing your data in a required data model format. You will find a Plunker demo in our wiki documentation demonstrating these customization steps in detail. Interactivity is an important feature in our data visualizations. So we implement event emitters and listeners by default. That's why when we integrate multiple data visualizations on the same page, they interact automatically. Though you can choose an option to switch off these interactions. The animation here shows our molecular detail page implementation for PDB entry 2RIA. You can see how easily a user can navigate around 1D, 2D, and 3D views and can easily explore the data and additional annotation in multiple contexts. Interactivity between data visualizations is automatic. So if you want to establish interactivity between data visualization and your application, you have to do some additional steps. To accomplish this, we provide helper methods that allow programmatic control of the visualization. You can programmatically set a specific data visualization view on some user activity in your application. For example, if a user selects a specific record in some tabular data, you can update the visualization view accordingly. Here, as an example, I have mentioned 3 helper methods from PDBe Molstar. You can focus on a specific region using the first focus method. You can use the highlight method to highlight a specific region, and you can also remove any highlighted region using the clear highlight, which is mentioned in the 3rd and 4th line. All these methods are listed in the wiki documentation under helper methods section. To show you an example, here I have added a screenshot of the documentation section. You can see that the documentation details include the method names. You can see there are parameter details, and the information about expected values and their data types is also mentioned. In the documentation, you also find links to working examples demonstrating all the available helper methods. Helper methods allows us to make changes to the visualization. But what if you want to make a change in your web application depending on the user action in a visualization? So exactly opposite of what we saw in the previous step. To accomplish this, we provide custom events. In your application, you can bind to this custom events using event listeners and track user mouse actions inside a visualization. For example, here you can see an event listener binding click event of PDBe Molstar, and inside the callback, I just console log that data. Now, when the user clicks on a residue, we get that information in our application, and you can see all details in the tooltip, the 3D view tooltip are printed in the console log. We provide at least 3 custom events, click, mouse, or mouse out in our interactive data visualizations. All the available custom events are listed in the helper methods section in the wiki documentation. There are multiple ways to reach out to us. If you need information or help about any of our services, then you can write to us at pdbehelp@ebi.ac.uk. You can use GitHub issue tab to report any project related issues, or if you want to submit any new feature request, you can use the GitHub issues tab itself. If you are using any of our data visualizations, then make sure you subscribe to the GitHub Watch feature so that you will regularly notified about all the project updates in the future. Also, if you find our projects useful, then do remember to hit the GitHub star button. And finally, if you want to customize and use our source code, then we recommend you to fork the GitHub repository so that you can easily merge any updates which we release in our future releases. I have listed all the important resources URLs here for your references. We have created special GitHub pages to share the material discussed during the webinar series. Also, all the webinars in this webinar series are recorded and are uploaded on our YouTube channel. Last but not least, do follow us on different social media platforms. Our outreach team actively share news, updates, and more interesting stuff related to PDB over here. Thank you very much for your kind attention.